Okay, so today we are going to study functions that involve the natural base e. So e is a special number, just like pi is a special number. And then we'll also graph them. So where e came from was that, I don't know, one day somebody was bored and they decided to see what happens if they keep putting in bigger and bigger numbers for n in this expression 1 plus 1 over n and see to the n power and see what they get. So this chart just kind of shows you, this is out of the book, but just kind of shows you that as you keep putting bigger and bigger numbers, see how it starts just like at 10 to the 4th, it's 2.718, 10 to the 5th, 2.718, 10 to the 6th, 2.718. It starts approaching a single number. And so that single number is called e, and it is irrational. And like pi, it can only be approximated because it never ends. So e is approximately 2.718281828459045. Now, do I expect you to remember that? No. You should have a scientific calculator, and in your scientific calculator, if you look at the LN button, which is usually over on the left side towards the top, above that LN button, it says e to the x. And so that's how we're going to get e in our calculator. Okay? It's over the LN button. Okay, so some examples. We can simplify expressions with e as the base, just like we did when we had numbers as bases, or variables, or you can just think of it as another thing. So if I have e squared times e to the 5th, that's going to equal e to the 7th power, because we just add our exponents when we're multiplying powers. For b, I would reduce the 3 and the 12, and then do I have more e's on top or the bottom? On top. How many more?
Just one.
Just one. So that would simplify to 4e. And then when we have a power to a power, we raise the numbers to the power. So 5 squared is 25. And then I multiply my exponents. So it would be e to the negative 6x. Okay? So we're just going to use our exponents rules to simplify it. So just to make sure you guys remember how to do those, do this one on your whiteboards. All right, looks like you guys are all getting it. Yeah, we just add the exponents, so e to the 11th. Okay, how about that one? All right, so we all agree it's 12e squared. How about this one? All right, looks like you guys are all getting 6e cubed. And here's the last one for you, 10e to the negative 4x raised to the 3rd power. Simplify it all the way so you don't have a negative exponent. Okay, so some of you are having issues with it. Okay, we're raising everything to the 3rd power. So 10 to the 3rd power. And then e, I multiply negative 4 times 3, negative 12x. Okay, the only thing that has a negative exponent there is the e. That's the only thing that would have to be flipped over. The 10 cubed is still on top, so 1,000 is on top of our fraction, and on the bottom we have e to the 12x, because after you move it, it's no longer negative. Okay? So that's that one. All right, next page. Okay, so now let's evaluate these using a calculator. So on your calculator, like I said, you should have a little LN button, and above that is e to the x. So you're going to hit your second button, and then your e to the x, and you're going to raise it to the 4th power. So let's see what you guys get for that. Go ahead and give me 3 decimal places on these.
54.5.
Okay, my bad, there's no caret button. You just hit the floor afterwards, so sorry about that. Okay, so what did you guys get?
64.67.
Wait, did we round? We'll go ahead and do these to 3 decimal places, so 54.598. All right, go ahead and do this one. Now, what you have to be careful on this one is because it's negative, you're not going to use the subtraction sign. You need to use the sign that has like parentheses around it, like this. This like a negative sign, it's usually like under, well, mine's under the 3, and that makes it negative. So you do your second e to the x, and then you hit that negative sign. You got it. Look under the 3. So it looks like most of you guys were getting 0.914 if you round it to the 3rd place. Okay, so now let's talk about graphing them. Your favorite part, I know. I did say graph. Okay, so the natural base exponential function. All right, so it's the form y equals ae to the rx. ae to the rx. So if a is greater than 0 and r is greater than 0, it ends up being exponential growth. And if a is greater than 0 and r is less than 0, then it becomes exponential decay.
So A is always going to be greater than 0.
Right, and because as soon as a is negative, then you flipped it over, and so that kind of changes whether it's growing or decaying. I kind of think that still technically it's growth, it's just growing towards negative infinity, but that's how your book has it, is that a is greater than 0. So I'm just relaying what the textbook publishers say is the truth. So it's one of those things that kind of depends on how you look at it.
So if you get a that's less than 0, less than 0, you automatically know it's neither growth or decay?
You know it has to be flipped over. And I'm not going to ask you if it's growth or decay. Because like I said, that's one of those things that's kind of like your point of view, how you look at it. So you could argue either direction. Okay, so just like before when we had our other exponential graphs, you still have an asymptote. And it's still y equals 0 for the x-axis. And we still have the same domain and range. Our domain is all real numbers, and our range is y is greater than 0. So that's the same as it was before. This is just a special exponential growth or decay graph. But really, you guys have already been doing these. So it's still going to be the same process. You're going to make a table, and you're going to graph it. So it's basically the same as what we've been doing all week.
So when you make the table, do you use 0?
When you make the table, I'll be doing that on the next slide. You're going to plug in -1, 0, 1, and maybe 2. All right, so let's look at this first example here. So I've got y equals 3e to the 0.25x. So first of all, do you guys think this one's going to be growth or decay?
Decay.
Growth.
Be careful.
Decay.
No, it's growth. It's growth. It's growth.
How did we decide whether it was growth or decay with this one?
Oh.
The base is 2.71 blah 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 blah. So for this one we're using r, aren't we?
Yeah.
Yeah, so that is a positive. It's a positive number, so it's growth. Because I'm raising 2.718 to a positive power, so I'm not flipping it over. But if that was negative, I'd be flipping over my e, and it would be 1 over 2.718, which is between 0 and 1. So when it's a negative, that's why it's a decay. Because remember, e is just a number. Okay? So if it's positive, I'm not flipping it over. that means that it's growth. Okay, so it doesn't matter that it was a fraction that I multiplied x times. What matters is whether it's positive or negative when we're talking about the natural base exponential functions. Okay, so then you just make yourself a table. So I'm going to use -1, 0, 1, and 2, just to give myself enough points to see what it's doing. And so for each of these, I'm just going to plug in -1 for the x. So for the first one, I'm going to have 3e to the negative 0.25 power. So you just plug that into your calculators. And we get 2.336, etc. Since we're graphing, when you make your tables, really 1 decimal place is probably going to be enough because it's not going to be that precise when you graph it. So if you just...
So you do 3 second E, and then you...
Okay, so then if it's to the 0 power, that's just 3 times 1, so 3. And then 3e to the positive 0.25 power comes out to 3.85, so we'll just say 3.9. And then when I put in 3e to the 0.5 power, because 2 times 0.25 is 0.5, I get 4.9. So then you just plot the points. So -1, 2.3, 0, 3, 1, 3.9, 2, 4.9. And that's enough to give me an idea of what my graph is doing. And so it would look something like that. And so just like before, my domain is still all real numbers, and my range is y is greater than 0. Yeah, so the asymptote is y equals 0. All right, so because of time, I'm not going to have you guys do one, but I do want to really quickly show you another one. So for this one, when you have one that's in this form, it's the HK form. So I've got my H and my K. So you're going to do this the same way that we've been doing them. It's just now we're going to move our origin, or pretend that we moved our origin. And so H for this one would be +2, which means I'm going to the right. K is 1, so I'm going up. So I pretend now that the 0.21 that is my new origin. And then you still would graph it, you would just graph it using the parent graph of y equals e to the negative 0.75x. And you would figure out a table using those. So what we end up with on our table for that when we plug in -1, 0, 1, and 2, at -1 I get 2.1. At 0 I would just have 1, and then I get 0.47 and 0.22. And so again, you would just pretend that that's your new origin and graph it based on that. -1, 2.1, 0, 1, 1, 4.7, and 2, 0.22, and you would graph it from there. Are there any questions? All right, that's it for today then.